Good evening all. Good evening. How are you all?
Fine, sir. How are you?
I'm fine.
Good to know, sir.
Thank you. So shall we go with the quiz today? I mean, as Lalit asking yesterday, he was asking for the quiz, but we couldn't conduct the quiz in last class today. So I'm okay to conduct today. Shall we conduct and shall we start a new topic?
Sir, we'll start a new topic first.
Sorry.
Sir, we'll start the new topic first.
You don't want to write a quiz?
I don't know, sir.
Sir, we'll play a quiz.
Tell me, guys. What shall we do? Quiz?
Sir, we'll play the quiz and start the chapter.
Okay.
Sir, which chapter are we starting?
I'll tell you. First of all, which topic we will go with? I mean, shall we go with quiz or new topic?
Sir, quiz.
Sir, new topic.
Give you a poll. Make it fast, guys. Test of divisibility, rational numbers. We have all done. Polynomials we done. Coordinate geometry we done. Triangles we are going to start today. We'll go with the triangles today.
Okay, sir.
Tell me, shall we start with the topic or new topic or directly first quiz, then we'll go with a lesson?
Yes, sir.
See, how many of you want to
Sir,
write a
anything
quiz?
is okay.
I'm asking you, how many of you want to write a quiz first? Put your message.
Sad on this.
Put your message. Put your message. Sahasra quiz, Lalit quiz. Make it fast. Nitya quiz. Okay. Make it fast. Okay. Make it fast. Quick, 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 quick. See, raise your hands. Okay. Raise your hands, those who want to go for quiz. Raise your hands, those who want to go for quiz. See, no problem. Only for. What about you people? How many of you want to write a quiz? How many of you want to write a quiz? Okay. First, these people want to start with the topic, so let's go with the topic. Then after, last 15 minutes, you remind me, Lalit, Sahasra, Ayush, Nitya, remind me. We will go with the quiz. Okay. Clear. So let us talk about the triangles. Look at it, sir. What do you mean by triangle? There's a better look at it, sir. If you just read each and every line here. Every figure has a shape, of course, size, position. If you are given two figures, then by simply looking at them carefully, we can decide whether they are of the shape or not. Very simple. If two figures cover each other exactly, then clearly they are of the same shape, same size. We can just easily figure it out. So these two figures are called as congruent figures.
Sir?
Yes.
Sir, you are doing any on whiteboard, sir?
Sorry.
Sir, have you shared your screen?
I'm sharing the screen. Why can't you see?
No, sir, we are seeing black screen. Ah, yes,
Yes,
sir.
so now it came. Before it was like just came a black screen.
1 second, I think. Now what I'm saying is
I'm
better.
also seeing black screen, sir.
But
Now
it's
can you?
not the black screen. I think we should wait like 1 minute.
Can you see it now?
Yes, sir.
Yeah. So beta, we are starting with the triangles actually. Triangles is nothing but what beta. Before getting into the triangles, you must understand what exactly the job, I mean, like, what exactly we are going to learn in the triangles. Okay, beta. So basically, like, if you have any shape, okay, if you have any shape or any figure, whatever, like, you just, like, will be deciding by looking at, in fact, like, every shape, and every figure will be having shape, size, and, the dimension, everything will be having, right? So by looking at the two figures, we can compare what is their size, what is, like, how shape it is, how length it is, how breadth it is having. We can just easily compare that each other, right? If at all, if two figures are same, if two figures cover each other exactly, then clearly they are same shape and same size. If they are having same like size, same figure, okay. So what did you teach? Adya, I'm going with the triangle lesson. Okay, be on time, please. So we can, by comparing two figures, beta, whether look at, first of all, let me say this is a figure here, this is a figure. Now look at this, I can just easily compare these two figures. They are not even related to each other, they are not looking same. If I just talk about like a triangle, if I talk about this triangle, yes, they are looking like the same shape, same size almost, and what do you call that, and they are locating in the same position. Okay, they look in the same position. I mean, the position of these two figures and the size of these two figures, shape of these two figure, I can identify easily. So if at all two figures cover each other, very important, look at this everyone, read, book reading is very important. If two figures cover each other exactly, then clearly they are same shape and same size. Okay, if they are covering each other is nothing but, for suppose if I have a triangle, beta, this is a blue color triangle. Okay, if I write one more, if I take one more triangle on the top of the blue color triangle, if it is exactly matching the same, then you could say that they are having same shape at the same time, same size. How? If they cover each other, if I overlap both the triangles on each other, what happens? They must cover each other, they must give. If I talk about this is a triangle, okay, if I talk about another triangle called, let's say this is a green triangle, okay, if I just place over other, what happens? That should match each and everything same. Their side should be equal, and the shape and everything should be equal. Then clearly, what can we say, beta? They are having same size and same size shape. So then these two figures are called as what? Congruent to each other. What is the beta? Congruent figures. If they are having same size, same shape, what do you call them? Congruent figures. Remember, very important word, congruent. This method of comparing two figures is known as method of superposition. In this chapter, we will study the basic criteria of congruency of special figures. What we'll be studying, beta? We'll be studying about congruency of special figures. What is the congruency? Just now I told you. If two figure, if two figures cover each other, then exactly we could say that they are having same size and same shape. So then these two figures, then that type of figures are what called as congruent figures. So very simple point. There is nothing much to remember anything here. Very simple. Now better look at. Let's talk about this congruence of two figures. Congruence of two figures is what? Let's talk about that. So two geometrical figures in a plane are congruent if, without bending or twisting, we can superimpose one figure on the other so that two can be brought into coincidence. So that is what the point I told. He is technically, some grammatically neatly he is writing, but in our daily language, if I talk about, if I place a figure on the other figure, that must match with the sides, the shape, and everything. All right, that must be properly fit to over there. One figure must fit over other figure. So in such cases, I would say that they are congruent to each other. All right, so here what's happening, try to read the line again. Very beautiful line, very good, important point. So everyone, let me just go through the look at this here. So two geometrical figures in a plane are congruent if without bending, twisting, we can superimpose one figure on the other so the two can be brought into coincidence. If I am able to coincident them, if I'm able to coincident them, I could be able to say that they are congruent to each other. Very simple. Look at this here. He has given a beautiful example. Let 2 points he has given. If two lines are congruent, if and only if they have same length. Very important. Very important. But if these points are very important points. When can you say two figures are? I mean, two line segments are congruent to each other if they are having same length. For suppose you has taken a AB line segment, CD line segment. If they are having same length, if they are in a same length, all right, you could say that AB is equal to CD and AB and CD are what called congruent line segments. I'm talking about line segment, right, beta? They're having same length. Then I could say that AB and CD are what congruent line segments. Understood my point? What is the ultimate criteria? They must have same length. For whom? For line segments. For what? For calling congruent to each other. Understood my point, children? Any
Yes,
doubts?
sir.
Any doubts here? It's a pretty simple. Very, very
Sir,
simple.
sir,
Yes.
tell once again, sir.
Sorry.
Sir, tells once again, sir. I didn't understand.
Okay. So look at this. Congruence of triangles. Congruence of two figures. So this is a look at it. If I have two figure, if I have two figure, when can you say two figures are congruent to each other? If they are having same size, if they fit each other, if I'm able to, if I can able to coincident each other, I can say that they are congruent to each other. So congruent of two figures he is talking about here. Now what he is talking about? He is talking about first point. What first point says here? Two line segment are congruent if and only if they have same in line, same in length. Look at the AB is a line segment and CD is a line segment. They are having same in length or not? Nihal, they are looking like same or not? Are they in same length or not here? Yes,
Yes,
they are
sir.
in. Yes, they are in same length. So I could say that AB and CD are congruent line segments. What they? What are they? They are congruent line.
Congruent.
When can you say they are congruent? If they are having same length. Very simple. Next point,
Sir,
what is yes?
in that lines, length and breadth are so. Everything should be same, sir.
Sorry.
Sir, everything length and breadth both should be same, sir.
You will not be having any kind of breadth over here. Understood? In line segment, you will not be having any kind of breadth. Only length will be line segment. What is a line segment, man? Line segment is nothing but what? This is a line segment, isn't it? This line segment and this line segment both must be same. You shouldn't have any, there will not be any kind of breadth for this. I'm talking about length. Both should be the same length. Okay. If I talk about a geometry, like if I talk about a rectangle square, then I would be taking the breadth. Okay. Do you find any breadth over here?
No, sir.
So I'll tell you that. Do not worry. This is what now we have discussed. They must have same length. So I could say that they are congruent line segments. Now two angles are congruent if and only if they have same angle measure. For example, BAC is equal to DEF. BAC and DEF are said to be congruent angles. Very simple. Let me explain you this point. Beta, what we have learned in the first point, if two line segments are, they are in the same length. If they are in the same length, I could say that this line segment and this line segment, this line segment and this line segment having. Wait, 1 second, what's happening is yes, this line segment and this line segment are in the same length. I can say that A, B, and C, D are congruent line segments. In point to what he says, for suppose this is angle beta, this is angle A, this is angle E. Here, if they are having, let's say that this is making theta angle, this is also making some theta angle. Okay, or else you say it is making, let's say this is somewhere 45 degrees. Okay, let's say this is somewhere 45 degrees. If both are 45 degrees, I could say that what is angle? What is this angle beta? BAC. BAC. What is this angle? DEF. Both angles are what? Congruent angles. Both angles must be same. Both must be all right. They must be same angles. They must be They must measure with the same angle. Then I could say that they are congruent angles. Very simple. Third point, let's talk about circles. Two circles are congruent if and only if they have same radius. Better look at this radius. Let's say this is radius is 1 centimeter. Let's say this is also 1 centimeter. Now they are having, since they are having same radius, I could say that they are congruent to each other. All right, they are congruent circles. All right,
Congruent
children.
circle.
Very simple. There is nothing to worry much. So beta, we have spoken about what you have spoken about: congruent of line segments, congruent of angles, congruent of circles. Yes, 3 points we have discussed. Now let us talk about congruence of two triangles. What is that? Congruence of two triangles. Basically, congruence of two triangles is nothing but what? What exactly this topic demands from us? But two triangles ABC. Look at this, ABC. This is a triangle, and DEF are congruent if and only if all the sides and all the angles of one triangle are equal to the corresponding sides and angles of the other. Very good point. Look at this. Understood my point? Look at this here. Everyone, if this is ABC triangle, DEF triangle are congruent if and only if all the sides and angles of one triangle, all the sides and angles of one triangle are equal to the corresponding sides and angles of the other. For example, look at this here. Here, A. What is the position? This is one triangle, beta. First triangle. This is a first triangle. ABC. DEF is a second triangle. What is the corresponding position of A in the second triangle? D. Correct, corresponding angle. What is the corresponding position of B in a second triangle? E. What is the corresponding position of C there? F. All right. Understood my point? That is what he has denoted with single line, double line, three lines, something like this. Understood my point? So
Sir,
1 second, let me finish. You can ask. Let me finish. Let me talk. I'll give the time. Don't interrupt in between. I'll give time to everyone. You may ask. Okay. So this is the first figure and this is the second figure, beta. So here now AB and ED both are equal. BC, EF both are equal. AC, DF both are equal here. Understood my point? Then what can I say, beta? I could say that triangle ABC congruent. Congruent symbol is what? This is a congruent symbol. How? This. If I write only this is similar. What is the symbol? Similar. And if I write this is similar and equal. If I write similar symbol and equal symbol together, if I write like this, wait. If I write like this, similar and equal symbol together, that is what? Congruent. Okay. So this is what the basic understanding. Now look at this here. AB is equal to DE. BC is equal to EF, CA is equal to FD. Don't remember here. Hello. Compare what's happening here. Just look at it and look at that and observe it. What's happening? I told that corresponding sides and angles of one triangle must be equal to all the sides and angles of one triangle must be equal to the corresponding sides and angles of other. Very simple. What exactly? What is the tricky part here? Very simple, right? Here, look at it. Then I can say that triangle ABC is corresponding, congruent to triangle DEF. When can I say that? When can I say that? If at all this AB is equal to E, look at this here. This AB is equal to E. Both are equal. And BC is equal to EF. If BC is equal to EF. And let me talk. AC is equal to DF. If that is equal, if they are corresponding, they are corresponding sides, right? Of both the triangles. So I could say that this are equal in both the triangles. Okay, now angle is A is equal to D, angle B is equal to E, angle C is equal to F. They are corresponding angles and they are equal to each other. Understood my point? So if that is happening, I could say that both the triangles are congruent to each other. Now you ask me if you have any doubts. So
sir, corresponding means what, sir?
corresponding means, I'll tell you, wait. Look at this. Here, this orange color side you have, right? This orange color side.
Yeah, sir.
That is one side. And this side. This orange and side are corresponding sides of both the triangles. Same side. Okay.
Okay.
What is the left
Okay.
side of what is the left side of ABC triangle? This orange one. What is the left
Yes.
side of DEF triangle? That green one. The green and orange both are corresponding sides of both the triangles. Now you understood better?
Yes, sir.
Now what is the corresponding side of what is the corresponding side of what is the corresponding side of AC in DEF triangle?
DF only, sir. AC and DF, sir.
Ipudu look at this. Here AC. What is the corresponding triangle of AC in DEF? DEF. All right. What is the corresponding side of BC in DEF triangle? EF. Isn't
EF.
it? So that is
Yes,
what
sir.
corresponding. Same
Okay.
thing. It follows with the corresponding angles also. Okay. So now basically,
Okay.
if very important note you will be using in 10th standard as well. Note corresponding parts of congruent triangles are equal. What is it? Corresponding parts of congruent triangles are equal. Congruent triangles, he said. You say the simply that as CPCT. CPCT means what? Corresponding parts of congruent triangles are equal. That is the meaning of CPCT. He has written in a short way.
Yes, sir. So like if its triangle is congruent, so automatically other parts also will be congruent by
Exactly.
CPC.
So corresponding parts of congruent triangle. First of all, they must be congruent. If that is the case, their corresponding parts would be equal. That is the meaning of CPCT. Okay. Understood? Any doubts?
No, sir.
No. Yes. One second. I think. Okay. So next, look at this. He has given a point here. Everyone observe this. What is the point given to you? If two triangles are congruent, then their corresponding parts are equal. Yes. If two triangles are congruent, their corresponding parts are equal. Very simple. So now let us talk about criteria for congruence of triangles. Criteria for congruence of triangle. What is the criteria? What is the criteria for congruence of triangles? So this is very important topic, but everywhere it will be useful. Listen to me carefully. So side angle side. I would say that SAS. SAS is nothing but not sauce. Tomato sauce, chili sauce, ऐसा नहीं होता है, ठीक है? Side angle side. Rule for congruency of triangles. What is it, beta? Rules for congruency of triangles. What is which congruency we are talking about now? SAS rule. What is SAS
Yes,
rule? Side angle side
side angle side.
of congruency. SAS rule for congruency of two triangles.
So like the angle must lie between the two sides.
Yes, angle must be lies between two sides. We will see that. Very simple. Look at this here. So what is the statement here? Statement is nothing. Very simple, Babu. Statement, whatever the SAS have given here, that is what your statement is all about. Now let me just underline. If two triangles have two sides, two triangles, two sides, and included angle of one triangle equal to the corresponding sides and the included angle of other triangle, then the triangles are congruent. Sir, what is this? We didn't understand anything. I'll tell you. If two triangles have two sides and included angle of one triangle equal to the corresponding sides and included angle of the other triangle. Very simple. I'll tell you. Look at this here. Let me just geometrically let me show it to you. But what is saying? Two sides of two triangles. This is one side of one triangle. This is another side of another triangle. Okay. This is a second side of one triangle. This is a second side of another triangle. Two sides.
Your voice is breaking.
1 second. Now can you hear me? Two triangles have two
Yeah,
sides
sir.
and included one angle. What is the included angle in between? This is the angle included in between the A angle. Okay. Included angle of one triangle if this angle is equal to this angle. Okay. Equal to the corresponding sides. But this, look at it, this red color side and this red color side must be equal both. Understood my point? And this angle is the red, this angle, green color angle, both green should be same, both red should be same. I'm just showing you by highlighting that. That is what SAS rule is all about. If two triangles, read that statement properly. Two triangles have two sides. This one side is another side. Included angle. 1 second, let me erase it and I again highlight it. Two sides, one side, the another side. Okay, this two sides must be equal to two sides of this triangle. Very simple. Now, what is just given? This angle of first triangle must be equal to this angle of second triangle must be equal. That's it. So he has given, look at this here. What he has given here? Given part is what? In triangle ABC, triangle DEF, in which AB is equal DE. I told right, this is equal to this. That is why he has given one line here. Guys, what is a mark? What is this indication here? What is this indication? One line, but which is nothing but they are both same.
They
Two
both
lines, nothing but both are equal.
yes,
Okay.
sir.
AC is equal to DF, and here A is equal to D, which is nothing but this angle and this angle both are equal. Cool. So what we need to prove, beta? We need to prove that this triangle, what is this symbol? Congruent to this triangle. That is what we need to prove. How can you prove that? We will see now. Proof also given. Let me just explain each and everything neatly. Okay. Any doubts here till this? Till this, you people have any doubts? Guys, understood or not?
Yes, sir.
Now look at this.
Yes, sir.
I have given the time to observe. Okay. Now, any doubts so far? No. Cool. See here, this is a triangle ABC, right? This is a triangle DEF. How they must be congruent? For that, what we have to do? Here, A. What this A is that? A must, A falls on D. A falls on D, and AB falls on DE. This AB falls on DE. Guys, let me use corresponding colors so that it will be easy for you. Look at this one. This A angle A, right? This angle must fall on angle A. Okay. And now look at this. AB must fall on DE. Okay, I'm using corresponding colors. Try to observe it properly. And AB falls on AB falls along DE as given. Yes, obviously, since AB is equal to DE, so how B falls on what now? If these two are equal, right, beta? Both green lines are equal, both orange lines are equal now. Then what happens? This B will go and falls on E. As simple as that. What I'm trying to say, beta, take this triangle and place on this triangle, Babu. If they are matching every sides, every angles, then you could say that these two triangles are congruent to each other. That's it. Take this triangle, place over here, place on this triangle, on the top of this triangle. Check whether all the sides, all the all the sides, angles overlapping on the triangle or not. You have to check. Cool. So here AB is equal to DE. So B falls on E. That is what the point given here. And this blue angle and this blue angle both are equal. AC will be what? AC what? This AC is right. This AC will
To
be
DEF.
DF. Very simple. Now what happens here? AC is equal to DF. That is what he has given here. Now so what? Therefore C will be falling on what? F. Very simple. Guys, generalize, think common sense. Just think two triangle, you take two triangles, or else you cut two papers in the shape of triangles and just make sure that you are placing one paper on the other paper. So, and give the name of that A, B, C, D, E, F. Check which vertice, which vertice, this you call this as vertices, beta. Which vertices is places on which vertices of both the triangles. Check it out. Here, since angle A is equal to D, AC will be falling on DF. So C will be what? Falling on F. Very simple. So AC will be what now? AC will be coinciding with DF. AC will be coinciding with what? Babu, this will be coinciding with this. That is what he has given. So therefore, BC will be coinciding with what now? BC will be coinciding with what?
Yes.
EF. EF. And now triangle ABC coincide with this triangle. Can I say now this triangle is congruent? Is nothing but congruent. That symbol is equal to
SS
triangle.
criteria.
EF. That's it. How do you say this? By, if you want to prove me practically better, you just, I'll give a I'll give a simple logic trick here. Cut papers in the shape of triangles in the same size, give the names and compare. Very simple. Any doubts?
No doubts.
No, sir.
Sir,
Hmm.
sir, I didn't understood. Also, AAC from there I didn't understood, sir.
You don't read all that, man. If you read that, you won't understand. Very simple. If you read that, he has given. You need not to remember all that, Nihal. I'll tell you one simple logic here. See, you take two papers, or else, or you take two figures which are in a triangle shape. Okay. Now you take this figure. Okay, first this is the first figure. You take this figure, a figure place on the second figure. Means like just keep on the second figure. Place the first figure, keep on the place on the second figure. Then what happens? If I place this first figure on the second figure, this A will be matching with the D, this E will be matching with the E, C will be matching with the F, and this angle will be matching with this angle. In case these all are happening, I would say that that first triangle is congruent to second triangle. That is what he has written over there. What is there to understand? Tell me. Any doubts?
No, sir.
Huh. Yes, understood, guys.
Yes, sir. Understood.
Very good. So if this is happening, we could say that they are congruent to each other. What is this says beta? What is SAS says here? What SAS? What SAS says? SAS. Side angle side.
Good angle triangle.
Side angle side. Side angle side is nothing but these two corresponding sides. At the same time, this angle must be equal. Understood my point? Two sides and included angle of one triangle is equal to corresponding sides and included angle of the other triangle. Okay.
Okay, sir.
Very simple. Look at this. It is very, very, very important. Look at this. Remember, he is highlighting. Remember. Okay. Dekho, he is like showing you showing you like this. Remember, it is very important that equal angles are included between the pair of equal sides. So SAS congruence rule holds, but not ASS and SSA rule. Understood my point? What he has given? Look at this here. let's say these two are same figures. Okay, this it is very important that equal angles are included. Look at this here. These two angles are included. Where they included? Between the pair of equal sides. This green color angle must be between these two equal pairs of sides. Understood my point? So SAS congruency rule holds, but not ASS. ASS is nothing but what? Angle side. How come possible it is? How come it is possible? First angle coming, then side by side. How come it is possible? This holds, beta. This is, look at this, it is very important that uh, the equal angles are included. Where it included? Between the pair of equal sides. So SA is congruence rule holds, but not ASS SAA. Sir, you are saying that two sides we have here. Yes, yes. Can I write SAS as ASS and SSA? Can you write like this? You cannot write like this. You cannot
Yes,
write
so
like this. Why?
the angle
Because
should lie between the two sides.
angle must lie between two equal sides of both the triangles. Okay, guys. That is what very important. Now, same thing. We will go with angle, side, angle. I would say that shortcut. I would say in short, ASA. ASA rule for congruency of triangles. Okay, Lalit, within 2 minutes we will start with. Okay, guys, what angle, side angle says here? Two triangles are congruent if any, very important, any two angles, look at this, any two angles, and the included side of one triangle are equal. Included side of one triangle are equal to
Should lie
two
between them.
angles and the included side of the other triangle. Very simple. Look, I'll show you the figure to you. I'm talking about what? ASA. ASA. Look at it here. This is angle half. This is the another angle half. Okay. Both angle. What is the what he has given? Look at this here. Triangle ABC, triangle DF. Here ABC and DF both are equal. ACB and DFE both are equal. And this BC, look at it here. What is the side between these two angles, beta? BC and EF, right? What is the side between these two angles? BC. What is the side between these two angles? EF. They must be equal. That is what he has said. You understood or not? Very simple,
Yes.
beta. This side and this side. This side, this side. So whatever, sorry, angle. This angle, this angle, this angle, this angle. Whatever the side lies between these two angles, they must be equal, beta. And these two angles must be equal. That is what ASS is. That is what ASS is. Understood my point? So as per your concern, I'll stop here and we'll go for the quiz. I'll share these notes. Please go through this. Proof is going to be the same. There is nothing much to worry much about this. Proof is same, guys. Go through the proof. If you don't understand, I'll explain it again in the next class. So I'll conduct a quiz now. Just give me a minute. Everyone join for the quiz.
How many questions?
20 questions. 20 questions. I'm gonna start the quiz now. So everyone join for the quiz. One more guy has to join. Who's that? Make it fast.
So can you probably scroll it down?
Sir, can you share the result in the group?
Yes, yes, Lalit, I'll share it.
Sir, the quiz is repeated.
Yes, 1 second, guys.
Sir, you actually repeated this quiz, sir. It was already. So it would not be fair sharing the results of this quiz.
Sorry, who's this?
Sir, you actually repeated this quiz, sir. We already had this.
We already had the same quiz.
Yes, sir. Same exact quiz. Like I remember every one question.
Okay, then shall we go for
Sir,
the
don't. Yes, sir. Like, don't consider this.
yeah.
This would be
Same-
cheating because
Yeah,
it is the
same,
same quiz, right?
yeah, same quiz, right? Then it would not be fair. Okay, let me wind it up and then let's go
Sir,
for.
don't share the results of this.
I'll not be sharing the Babu. I'll be like ending up and I'll be going for the next quiz.
Okay, sir.
Anyway,
Sir, can you conduct another quiz?
yeah, 10 questions.
Sir,
Yeah, guys, if there is repeated question, you just have to let me know immediately, man.
sir, sir.
Wait, just a minute.
Sir, then only one question.
So you keep 15 questions, 20 questions, one more.
1 second, we don't have time. We have to think that as well.
Sir, 4 minutes left, sir. It would be enough for like 10 question quiz.
Yeah.
Sir, class 10.
Yes, it is class 10th only. Yeah. Make it fast.
Sir, how many questions?
10 questions.
Sir, just a minute, joining.
I
Sir, this quiz also completed, sir.
This quiz also completed.
Yes,
And
sir.
the questions are repeating, I think. Like, it is not that no, I'm conducting a different only, but
Yeah, sir, 1-2 questions.
make it fast, make it fast. Make it fast.
Sir, same quiz repeated. Not same, sir. Like you conducted this.
Sir, this was
You
the
conduct.
same quiz. I remember
Yes,
this
yes.
last
Tell me, tell
time.
me, tell me.
Sir, the last
Okay.
one and this one you conducted on the same day, sir. These two quizzes.
Yes, sir.
Okay,
These two
I
okay.
remember correctly, sir. That's why we are getting full.
Yes,
No
sir.
problem, no problem.
On
Okay,
Saturday. On Saturday, sir.
okay,
So
okay. Okay.
don't conduct, like, don't consider these two, sir. It wouldn't be.
Yeah, yeah, yeah.
Yes,
Okay,
sir.
Chetan, so I'm winding it up then. So no problem. Let's make a move now. Thank you. Have a nice day. Goodbye.
Thank you, sir. Bye,
Bye,
sir.
sir.
Bye, sir. Good night.
Bye, sir.
Take it. Bye.